We've covered terrestrial biomes. Now I want to move into aquatic biomes. Aquatic biomes are one of the dominant zones and biomes in definitely aquatic ecosystems. And I want you to understand their principal biological attributes. So we're going to learn about what makes it cool to live in the water compared to on land. Aquatic biomes, unlike land biomes, are typically going to be characterized by physical and chemical environments. We're going to talk about how different levels of light comes through the water column, and we're going to specifically talk about the chemistry, because temperature doesn't have as much of an effect in the water as it does on land. The primary the primary energy supplier in the ocean is the sun, just like on land. But the issue is, the deeper you get in water, the less sunlight penetrates. So you have some regions right near the surface where you have a lot of organisms that are photoautotrophic. They can convert the sun's energy into sugars. But as you go deeper, you start to lose these differing wavelengths of light. The reason that water looks blue is because blue penetrates the deepest. Red, orange, yellow, they get absorbed within the first 10 meters, so within the first 30 feet of water. Greens and blues go much, much deeper. But eventually it all disappears. At about 10 meters, you've lost 50% of the intensity of light. 30 feet down, it's about half as bright 50 feet down as it is at the surface. 20 meters, you've lost 25%. I'm sorry, you're down to 25%. 30 meters, 100 feet down, 12.5%. And it keeps dropping and dropping and dropping until you are in total black. Light just doesn't penetrate. The area that light does penetrate is called the photonic zone. This is not a very deep area. As you can see here, the photonic zone is roughly the first 100 to 200 meters. That's as deep as light can go. Beyond that, it's dark. It's aphotonic. That aphotonic zone is called the benthic zone. So you've got the photonic zone where light penetrates, and the benthic zone that light doesn't penetrate. And the benthic zone can go down for a long time. Well, the first 200 meters photonic, you get a little bit of light even at the bottom. Beyond that, up to 10,000 meters, it's black. Most of the ocean is black. As you descend, you're going to find what's called the thermocline. Thermos, we're talking about heat. The first few meters are generally pretty warm, especially along the equator. But as you descend, it gets colder and colder and colder. Why is that? Why does it get colder the deeper you descend? Right, no, not because there's no sunlight. It has something to do with the properties of water. Right, cold temperature drops because cold water is denser than warm water. Until it freezes, and then it floats. At 4 degrees Celsius, water is as dense as it gets. 4 degrees Celsius water sits at the bottom. Beyond that, you might have ice floating at the top, 0 degrees or below 0 degrees. But at the bottom of the ocean, it's 4 degrees. Have you guys okay, how about this? Ever jumped in a lake before? All right, this is the great part. You jump in a lake off of a boat. That top of the lake is pretty warm. But if you jump off of a boat, you're going to quickly discover a thermocline. There's one point where you jump in, it's like, oh, this is nice, and then your head hits the thermocline, and it's like ice cold. So you shoot back up as fast as you possibly can and hope you never get there that depth again. The thermocline is the region where warm temperature meets cold temperature, and it's a very, very rapid change. Here, you can see that where the line is almost horizontal, that's the thermocline. So worldwide, there's very, very little variation in the temperatures at the bottom of the ocean. So what do you expect about the organisms at the bottom of the ocean worldwide? They're very similar. They can easily travel back and forth between different areas. It's not the temperature that makes a difference for where they live. It's the chemicals in their environment that do. What's the pH like? What sort of sediments are being shot up from fissures? So there's not much variation by latitude. There's not much variation by longitude at the bottom of the ocean, where it's 4 degrees Celsius year-round. Here on this chart, you can see the thermoclines of the tropics, where it's maybe 20 degrees Celsius, 15 degrees Celsius, and in winter, maybe 10 degrees Celsius. But it will all drop very quickly until you hit a point where the high latitudes, the mid latitudes, and the equator all roughly hit 4 degrees Celsius. So to sum it up, there are different zones in the sea. The photonic zone and the aphotonic zone, the benthic zone. The photonic zone is going to have where light penetrating, where photosynthetic organisms can thrive. There's a lot of energy and there's a lot of life there. But as you go deeper, the light disappears. It gets colder. And there's less energy to go around. You're going to have more sparse life forms. It's not going to be as densely populated as the higher areas, but there's still life there. And the farther down you go, the more similar those organisms are to organisms all over the world. In fact, they keep pulling deep-sea sharks out of the ocean, different types of sharks. And they found the shark, the goblin shark, in Japan. They pulled the goblin shark out. It looked really weird. And they're like, wow, we've never seen anything like this. This must be unique to Japan. And then they start finding them all over the world because turns out they live deep and they can live in any deep environment. These organisms can survive because they're adapted to their specific ecological niche. So that you bring up the Greenland sleeper shark. I'm sorry, the Greenland shark and the sleeper shark. The Greenland shark and the sleeper shark are the same species. The goblin shark is slightly different. The Greenland shark and the sleeper shark are on. They were these deep water type sharks, very, very large, very slow movers. Their skin is actually poisonous to us unless you cure it, and because then it becomes a delicacy. It's the national dish of Iceland. It's terrible. You should go and have some. But they thought for the longest time, because these sharks lived in different parts of the world, they must be different species. But because they're deep water shark, they actually migrate.